Greetings everyone. Today we're going to explore how to simplify rational expressions. So we've dealt with the word rational before in the sense of rational exponents. So when we were dealing with x to the 1/2. So rational is going to imply a fraction or a ratio. And expression just means that we're going to simplify. There's no equal sign that we're dealing with. It's just a polynomial or an expression that we're going to deal with. We want to simplify it as well. So if we can reduce anything, combine like terms, cancel anything, that's our goal, is to simplify. You'll want to take notes in your notebook. We've got a few examples to go through, and you'll definitely want to pause at the beginning of an example to try that factoring on your own. So again, our goal is to simplify rational expressions accurately. Keyword accurately, this is going to matter. So again, just a quick review, you'd want to get this down in your notes, that rational expression is dealing with a fraction, also known as a ratio. The definition of a rational expression is the ratio of polynomials. I'm going to have a polynomial over a polynomial. To simplify, you need to know three things. First, you need to know how to simplify fractions, which means if you have, let's say, 3/12, you have to know how to reduce that down to 1/4. Cancel things. What that means is if I have an x squared over an x, and let's say I have a 2x minus 3 as a factor, I can cancel part of this. Now I put cancel in quotes because it doesn't really cancel, it just equals 1. But in the end, we're reducing that value down, we're canceling it down. And then of course to factor. So 3 ways to factor. You're going to do GCF, or you're going to use AC method, or if you have 4 terms, you're going to have grouping. So I'm not going to spend a lot of time on factoring. If you need extra review, look for our previous factoring video or in your notes. So let's talk about how I can simplify correctly. Let's look at 2 examples. Think of 2 numbers that add to get 10. If I have, let's say, 8 plus 2, and then let's say 12, I do 10 plus 2. I can't cancel the 2's, okay? I can't cancel the 2's because they are terms. You can't cancel terms. So one way to remember this is if I'm adding or subtracting something on, that's a term. It can't just go away. But if I have a factor implying multiplying. For example, if I have 5 times 2 and 6 times 2, I can cancel those 2's. So in this example, you can cancel 2 because there's a multiplication symbol separating those. So you can cancel factors, but you can't cancel terms. And that's why, because I'm adding or subtracting, nothing goes away. Because I'm multiplying, stuff can go away. So be very careful with what you can and can't cancel. So let's take a look at some examples. The safe bet on all of these, to be honest, is to factor first. If you always factor first, it's easier to see what can and can't cancel out. So for example, I'm going to factor out a GCF here. So I'm going to take out a 20, a 2x plus 1 is what I've got remaining. I can divide out a 10. That leaves me with x plus 3 remaining. So now if I look, I have 20 times this, 10 times this, which means I can reduce the 20 over 10. That reduces down to 2 over 1, or just 2. And then these factors aren't the same, so they're not going anywhere. I'm keeping them in parentheses for now to show that they are factors. They do not cancel. So all I did was simplify the rational expression. I reduced it down. Now, one way I can sort of check to see if I'm comfortable in my answer is to use 1 to check, to at least make sure that what you have is equivalent. So for example, if I plug 1 in here, I would end up with 40 plus 20, and 10 plus 30, which would give me 60 over 40, which would give me 6 over 4, 3 over 2. I mean, you could reduce it all the way down. So now let's look and check in my reduced values. 2 times 1 is 2, 2 plus 1 is 3, 1 plus 3 is 4. This would give me 6 over 4, which reduces down to 3 over 2. So sometimes you might not have reduced all the way, but it's still worth checking to make sure that you have equivalent fractions, equivalent ratios. So use the number 1 to check. Now we can't use 0 to check because you're going to have a lot of denominators. We're dealing with fractions, and if I end up with a 0 in the denominator, I can't do that. So that's undefined. So stick to the next easiest number, which is 1. Use 1 to check and make sure they're at least equivalent. All right, let's take a look at factoring this down. First thing I see is a GCF. GCF of 2x, which leaves me with an x plus 4. And I have a monomial, so I can't really take anything out of that. So now if I look at my factors here, these factors can reduce down. 2 over 12 reduces down to 1 over 6. X over x reduces down to 1, and I still have my factor of x plus 4. If I check using 1 again, on the left side here I have 2 plus 8 over 12, which would be 5 over 6. If I check over here, I'd have 5 over 6 if I plugged in 1. Those are equivalent. So at least make sure it's equivalent. It might not be reduced all the way, but this is a good way to see if you're on the right track. All right, let's do a little more factoring. In the numerator, I can take care of a GCF of 2x, x plus 5. Now in the denominator, I have a quadratic, which means I need to use AC. So please pause this video, practice the AC method, because you need to know how to do this. So if I start with my AC, 15 is on top, 16 on bottom. That means my factors are 15 and 1. So my middle term separates out into 15x and 1x. If I group, I could take a 3x out, x plus 5. I could take a 1 out. I have to take something. Same thing twice. So my factors, I'm just going to fill them in right away, are 3x plus 1 and x plus 5. So look how easy it is to see what can cancel in the sense of what divided by itself is 1. So x plus 5 reduces down to 1. So complete simplified would be 2x over 3x plus 1. That 3x plus 1 is a whole factor, so it's got to stay together. It's a binomial. Let's do a quick check. If I plug in 1 into the original question, I'd have a 2 plus 10, which is 12. If I plug 1 into the bottom, I'm going to have, let's see, 19 plus 5, 24, which is a half. If I check 1 in here, I'm going to have 2 over 4, which is also 1/2. So at least they're equivalent, which means I'm on the right track. All right, let's take care of that denominator first because I see that that's a trinomial. Yes, I could use AC method, but I think taking a GCF out first would be helpful because that makes my numbers smaller. Now, please pause this video to factor that denominator. That denominator, negative 35, negative 2, which means I'm going to have a 5 and a negative 7. So that's going to simplify down to, I can skip grouping because my leading coefficient is 1. Again, if you're struggling with this factor piece, make sure you take a look at a previous video. Okay, I'm zooming through this because this is stuff you're going to be assumed you know from now on in every math class you take. So my denominator is simplified down. My numerator, take a look at that. Perfect square, subtraction sign. So difference of squares. If you need to remember that shortcut, then go look it up. It's in our notes. There's videos, YouTube it, Google it, difference of squares to make it easier. Or you always have the option, you could treat this as x squared plus 0x minus 49, and you could use the AC method. So if you don't remember the rule, use AC method. So in the end, this factors down to an x plus 7 and an x minus 7. So I can see those factors clearly simplify. X plus 7 on top, 2x plus 5 on bottom. Now, if you want to distribute that, you can. I'm not going to be picky about that right away, but for now, I'd just say just leave it because it doesn't make a difference either way. So that is my simplified expression. Let's do a quick check. Let's make sure I'm on the right track. So if I plug in 1 into the original, I end up with a negative 48. 2 minus 4, I'm plugging in 1, so 2 times 1 is 2, 4 times 1 is 4. So I'm kind of skipping over that. I'm just going pretty fast here. 2 minus 4 is negative 2 minus another 70 is negative 72. If I plug in a 1 into my answer, I have 8. 1 plus 5 is 6. 12, that reduces down to 2/3. Okay, let's see. 24 goes in twice. 24 goes in 3 times. Negative over negative, positive. So that checks out. They're at least equivalent. All right, so take a look at Google Classroom to see what else we did in class, see if you have an assignment and how we're going to continue. Let me know if you have any questions. But until next time, check Classroom, and we'll see you later.